Okay, so I'm actually going to flip over to my code view. I'm going to start out by creating a folder. I'm in the wrong spot. Right click, add new folder. I'm going to call this models. And inside of models, I'm just going to start off with a patient class. So let's kind of take this slow. So patient has things like first name, last name, patient ID, email address, and phone number. All right. So we have our class, and what I want to do is I want to then model that class in my database. Okay. So when you model a class in a database, the approach or the way that I like to think about it is for every class you create, and this is very simplistic, but for every class you create, you should have one database table that represents that class. Okay. Has everybody taken at least one database class up to this point? So you at least know how to do selects, and you know how to go in and create tables and add fields and data types for fields and all that. Okay. All right, we're going to cover and review a lot of that today as we kind of go through this, so hopefully you've got some basis for that. So if you make a class, patient, you should probably have a table, patient. The concept of relating the data from the database to your object is referred to as Object Relational Mapping, or ORM. There are tools out there that are designed to facilitate that process for you. Again, these are those black boxes I kind of talk about. And what they do is you say, here's the database, here's the object, make some magic happen, and take data out of that database table one row at a time, and for every row of data you pull, create one object. Okay? So your end result is if you have a table that's filled with 10 rows, you get an array of that object with 10 objects inside of it, or a list with 10 items inside of it. If you have a table with 1,000 rows, you get an array or a collection with 1,000 items inside of it. And every field in that table maps to one property inside of your class. Okay? So, how do we go about setting up the database and putting all of that in place? In my project, I'm going to add a new folder, and I'm going to use, and this is actually a convention from ASP.NET, I'm going to call it app_data. So I now have a folder where I want my database to live. Remember, this is for development purposes. We want to keep everything kind of in this little isolated package. In the real world, you would probably have a SQL server running somewhere else. You would have your database deployed to that SQL server, and then you would connect to it from that space. I'm then going to add new item into that folder, and under data, I'm going to choose a local database. Actually, it's a service-based database. And I'll call this CP Week 5 DB. So what Visual Studio is going to do is it's going to create an MDF file. It's going to ask me about creating data models off of either a data set or an entity data model, and I'm actually going to choose cancel. So all I want at this point is the MDF and the associated LDFs. If I double click on the MDF, Visual Studios will go through setting up local DB and connecting to my MDF. So I now have a connection to that database. Within Visual Studios, where I can manage it, I can add tables, views, stored procedures, functions, custom data types, all the above. This database is a true SQL Server database, so I can then take this out of my project and actually attach it to a full SQL Server instance, be it SQL Express, SQL Standard, SQL Enterprise Edition, any of the above, Data Center. So you have flexibility, and this is a true database. You're not dealing with an Access database or some sort of compact subset of SQL. This is a true SQL database. So if we right-click on tables, we can add a new table. Now, depending on your preference and how you like to work, Visual Studio 2012 gives you two modes of creation. You can type the SQL in to actually create the table directly, or you can use the designer above to build out your table. So for speed of work, we'll go ahead and use the designer. So the approach that I take is I say, I've got these fields, or I'm sorry, I have these properties, I need to build fields, so I just kind of match them up. So first name, and I usually do a varchar 400. Last name, varchar 400. Email address, varchar 400. Phone number, varchar 400. Now you may be wondering, why is he picking 400? It seems kind of like a semi-random number. When it comes to varchar or data types, when you're wanting to build indexes off of a particular field, if you covered indexes or recall what indexes are, indexes only work with fields that are of a specific length, and I forget the number off the top of my head, but a varchar field that is 400 characters or less is indexable. Anything over that, you can't build an index on that field. So if you want to have the maximum length string in a field, but still make it so that you can build an index off of it for fast querying, 400 is your number for a varchar. So.
How did you figure that out? The hard way or the easy way?
A semi-easy way. I looked up what the value was, and then I went and looked up what the byte length is for one varchar, did the math. I learned to look it up the hard way because I had an instance where I was trying to index a field that was far too big, because I was like, oh, varchar max, no big deal, and then all of a sudden I couldn't index those fields because they were too long. So that was kind of the hard way. Alright, so one of the things I have not been able for the life of me to figure out through this tool is how to go about changing the actual table name in this tool. So the only way that I've been able to do it is down here in the designer, or in the SQL mode. So people have different conventions about how they like to approach table naming. Personally, I like to put TBL in front of it, just so when you're dealing with a view that doesn't filter by view or tables versus views versus sprocs, you have something that's at least a quick and easy visual, and it kind of groups them together. Other people in some conventions will say, don't worry about it, just put in what it is. So it's preference at the end of the day. I want to make sure that this is my identity field. Properties. So I'll set my identity column to my ID, so it'll auto number, and we will update. Okay, so we can close the designer. If we go back to Server Explorer, we should be able to do a refresh, and there's our TBL patient. Okay, so we have a table. Table is empty. So if we do show table data, there's nothing inside. So let's put a record in. So we now have a table, has some data in it. Our fields match with what our properties are, so we have consistency. So now how do we take the data from the database and bring it into our application? The first thing that I'm going to do is I'm going to create another class, and I'm going to call it my database repository, or maybe just data. Make it public. And I'm going to add a method that returns a collection of patients. Okay. So the end goal is I'm going to have a list of patients have some stuff happen, and then I get all my patients and I return them back. Okay? So what is the stuff that needs to happen? We will need 3 objects in order to establish a connection to the database. We're going to need a connection object, a command object, and then we're going to need a reader or adapter. Okay? So connection object should be fairly obvious. It defines and builds the connection to the database. Okay? The command object is the command to be executed against the database. And you can think of this as your select, your insert, your updates, or your deletes. Okay? And then your reader/adapter, it is your mechanism or your kind of your class or tool for reading data from the database. Okay? So you build a connection. You then build a command saying, I want to select all rows from TBL patient. You take that command object and you say, use this connection when running that query. So the command object says, okay, I'm going to use this connection. I'm going to go out through that connection, run that SQL command. Depending on how you run that command depends on how you get your data back. In the most simplistic way, we're going to run it and ask for it to execute with a data reader. A data reader is considered a fire hydrant approach to reading data. It's forward only, read only. What that means to you and I is it will return back a pointer reference to the first record. It actually returns back a pointer reference to before the first record. And then we use a while loop and say, while we can read from the data reader, do so. And then inside of that loop, we then say, take the value from this field and store it in a variable. Take the value from this field and store it in a variable. That variable being the property of the object we're trying to populate. So we just loop one row at a time, and as we loop over those rows, we're pulling that data out of the database, basically making a copy of it in memory in our objects. So at that point, we're no longer having to deal with the database. We're no longer having to deal with managing the connection to that database. It's open the connection, get the data we need, close that connection, because those connections are expensive, and they're very heavily utilized resources. So just as another rule of thumb, whenever you're dealing with a database or writing to a file or working on with some sort of stream of data, web service, any of the above, those are considered exponentially very expensive. Because you have to establish a connection, you have to manage the networking protocol to establish that connection, you have to maintain it, you have to actually read the data from it, and then you have to go through the handshake process for termination. So there's a lot of resources that have to be kind of spun up and then spun back down when you make these out-of-process calls. So if you can do it quickly and efficiently and do it and get out of the way, that's your best approach. Traditionally, people would write websites where they would, the first line of code in the website or the web page was open a database connection. So it would open the database connection, and then the rest of the page would load, and then when it finally needed data from the database, it would go in and do its work, and then it would exit, and then it would probably do some more rendering, and then finally you got to the very bottom and it said close the database connection. Well, if something blew up between the beginning and the end, that became a corrupt or an unmanaged connection. So that connection would hang out there, and either the server would have to close it, or you'd have to run a cleanup process to take care of it. So just having these processes kind of living out there arbitrarily without really managing them and keeping them isolated, you end up with memory leaks, running out of memory just because of resource utilization, inability to connect, a lot of things like that. So be very cautious and really pay attention when you're trying to use these out-of-process resources. Okay? All right, so we need our objects. Since we're connecting to a SQL server, the objects that we're going to use are SQL-specific objects. All database-related objects or classes live inside of the system.data namespace. Underneath that namespace, you have a series of namespaces and other objects. Common namespace has all of your base class base classes for building any other kind of database connection. It gives you all the basic functionality, gives you all the basic plumbing, and all of the methods. There is an interface within the .NET framework that defines what a database connection object should look like, what a database command object should look like, a reader, and an adapter. If you're ever having the opportunity where you need to build your own set of ADO.NET objects, you want to make sure that you implement those interfaces because that provides you so much more flexibility and functionality in your application, and it removes the barrier of entry for someone using your tools because it follows the same conventions and notions, methods, and properties that all the other ones do. These base classes try to kind of give you a kickstart because it implements all of that at a very simplistic level. So you have DB command, DB connection. I think I blew right past it. DB data reader, DB data record. The data adapter was here at the top. You have data table mappings, factories, providers, a whole slew of things. IDB command is the interface that those implement. The namespace that we want to look at is SQL client. Okay. There's also ODBC, OLEDB, and there used to be an Oracle one, but now it's pretty much dependent on the ODBC provider to do that implementation. So if you ever worked with databases, those terms should be familiar. If you haven't, then if you ever hear the terms, now you know where to look. All right, so SQL client. Inside of SQL client, we have a SQL connection. I'm going to call it con. We also have system.data.SQL client.SQL command. Call it command. And then we have system.data.SQL client.SQL data reader. Okay? So those are our three objects or classes that we're going to interface with as we go down this road. Let's do this. Okay. So we have these variables basically. They're uninitialized, so they all equal null. They haven't been initialized to actually be an object yet. So that's our next step, is we have to initialize them and then we have to set properties for it. So we'll go through now. I said these were unmanaged resources. These are resources that live out of process. If you like to manage resources, which basically involves doing con equals new SQL connection, and then you have to do con.open, do work, con.close. Oh, but you got to hope there isn't an exception thrown, so then you got to do a try catch block. Scroll down here. And then you gotta close it here and manage the exception. You have to do all this work. Oh, and you have to make sure that if the con state does not equal closed, then you close it. Because if you try to close it and it's closed and it yells at you anyway, then you got to put it inside of another try catch block and it just turns into a hot mess. So you can go through and do that every time. Yeah.
Should we do a finally block?
And that was going to be my next point, is so instead of doing the close 3 times or 2 times, you can use a finally block. And what the finally block says is, try to do this work. If it works, excellent. If there's an exception thrown, handle it inside of the catch space. But regardless of if it works or it doesn't, you finally need to do this step. So we open the connection, we do work. If our work is successful, it says finally close the connection. If we try to do work and we throw an exception, the catch block we handle that exception. We log it, email it, throw it out to the user in some prettier way. And then once that is done, before everything terminates, we go to the finally block and we still close the connection. Okay? So that is one approach, a perfectly valid approach. Another approach, which takes the finally out of the equation, makes you not have to worry about closing it, is to use what is called a using statement. Is anybody familiar with the using statement? Go ahead. Tell everybody what it means. You're going to learn not to say yes to questions.
I already did for you, because I feel like I just sometimes don't even talk because I know it, and I'm like, I don't want to talk. So in this case, using connections with databases, using a certain connection to do whatever it's inside. That's like the most simple thing that I can say about it.
So then what happens at the end of the using block?
That part, I don't know, because I haven't used one in a while.
Okay. Anybody else? Okay. The using block is a simplistic way of managing unmanaged resources. So files, database connections, socket calls, network calls, any of those types of things. More specifically, if the class implements iDisposable. iDisposable is an interface that is per the logistics of the framework, or the convention of the framework. They say that if you have an unmanaged resource or a class that contains an unmanaged resource, you should implement iDisposable. What iDisposable does is it's a trigger for the garbage collection engine within the framework to say, if this class implements iDisposable, run the dispose method before you remove this object from memory to clean up any unmanaged resources. Using takes advantage of that information and says, SQL connection, if you, probably way back up here, if you implement iDisposable, when I reach the bottom of that using block, I will call your dispose method. The dispose method for the connection calls close automatically because its objective is to clean up that resource. The using block will call dispose even if an exception is thrown within it or you have successfully executing code. So it's kind of a safety net that regardless of what happens inside of this using statement, as long as we make it to the end, all unmanaged resources will get cleaned up. So this is kind of my preferred way of dealing with unmanaged resources because as long as I'm playing within the boundaries of that using block, I don't have to worry about leaving some connection unmanaged. Okay? All right, so we've initialized our connection. We need to set the connection properties, i.e. the connection string. So con dot, I already did state, so I won't really cover that one. Connection string, which is going to be probably your most important one. It is a string that is a unique format to the provider or to the database connection object that informs it of where does my database live, what is the name of the specific database maybe within that server that I'm connecting to, what's the username and password. All of that information is wrapped up inside of this connection string. So connection string equals, everybody writing this down? So you know how to connect to a SQL Server from now on? ConnectionStrings.com. Okay? Don't try to remember how to connect to a SQL Server database. Don't try to remember the connection string because you probably won't, or you're going to run into a scenario where you're not going to know exactly what thing to pass to it. You can go look it up in the MSDN documentation. It is this hot mess of all kinds of flags and fields and parameters, and most of the time I don't even know what X goes with which Y. Just being honest. Instead, I scroll down, I click on SQL Server, and I say I'm using the .NET Framework Provider, and it says, here's all the different ways that you could connect to that database. Using standard security, you would put past the server, the database, user ID, and password in that connection string. Trusted connection, and what a trusted connection means is that it will take your Windows credentials, assuming that you're running on a Windows machine, it will take the credentials of the user that the process is running under and pass those to the SQL Server for authentication. All right. That little last bit I kind of mentioned there is important. The user that the process is running under. When you're running it off of your local machine, you're running as the person you're logged in as. Probably on most of your machines, you're the local admin of the machine. It's no big deal. If you're running this, if let's say this was a web application or some sort of managed deployment, those applications tend to run with lower privileges than you do as the administrator on your box. So trying to connect to a SQL Server with lowered privileges or no privileges, you're basically going to get access denied every time you try to connect to that SQL Server. So that's just a factor to keep in mind. So it's if you're using the trusted connection, it's using the identity of the process, the user that the process is running under. Okay. Did you guys cover SQL instances at all? Named instances in your SQL class? All right, so basically you can actually spin up multiple SQL servers on one box, and you can give them all unique instance names. And the way you connect to a particular instance is you do server name / the name of the instance. So that's the connection string for connecting to an instance. Connecting via IP address, enabling MARS, which is multiple active result sets, so you're actually able to query the database and get multiple result sets back in one query request, so you can run 5 different select statements and get back 5 results simultaneously. It's pretty slick when you're trying to do optimized query execution. The thing that we're going to be using is local DB with a specific data file. And I think that's what I want. Instance, database mirroring, asynchronous processing. Okay. So I'm going to copy this as my template. And I'm going to paste it.
Just copied it right from the site.
Yep, copied it straight from the site, pasted it into my project. So now, what do we need to manage? What pieces of this do we need to take care of? What pieces of this can we leave alone? So if you look at it, you've got, and let me actually do this, let me break it so that you can see each element for what it is. All right, so the first element is the server. When you're dealing with local DB, currently version 11, which is the current version of SQL Server, SQL 2012. Connecting to local DB is always going to be, in parentheses, local DB / v11.0. That's the instance name. That is the default instance of local DB that runs inside of every instance of SQL Server 2012. Unless you didn't install local DB, then it's not there. But assuming that it's installed, that's what it runs as. Integrated security equals true. That means that for this application to authenticate to local DB, it's going to take the user's credentials that the process is running under, which will be myself, the administrator on the computer, and it's going to pass those credentials to local DB. It's going to say, I, Gantos K, am the person running this process. I'm therefore the person attempting to connect to the database, access permitted or denied. Since I'm the admin on the machine, the SQL Server is running on this machine, I automatically get access to the SA account. Full admin rights. The third piece is attach DB file name. This is a full path to the MDF file that we created 5-10 minutes ago. This we're going to have to adjust to make sure that it's pointing to the right place. Now, there's a few ways to go about this. We could hard code it. I could just jump out to my Solution Explorer, right-click on App Data, say Open Folder in File Explorer. I will open that folder. There's CP Week 8 DB. Jump up here, copy that part of the path, come in here, delete, paste, CP Week 8 DB.mdf. Good as gold. Will that work for you when you're submitting your projects to me? No. Because then I have to go and I have to go find your connection string, and I'm hoping it's only in one place in your program. Because it should be. Shouldn't have to go digging all over for it. Wink, nudge, hint. I have to go find where I saved your project to. I have to update the path. Pain in the butkus. So how do we do it so it's dynamic? How do we do it so that I don't have to go search for it? Or if you run it, if you save it on a thumb drive and you take it home and you run it on a different machine, or you bring it here and then you plug it in on a lab machine, whatever, juggling that so you don't have to manage that connection string every time. My approach is I cut the string right there. I then say con.connectionString plus equals. You can then say environment dot current directory which will give you the root executing directory for your application. Where did my application start running from? Actually, there might be a better one now. All right, we'll go with that. Environment.current directory plus, I put it inside of a folder called app data, app_data, and then it's cp week8db.mdf. Need to double escape my slashes. There we go. So I'm taking the current directory and simply saying that plus app_data / and the database name. Because the database name is not going to change. It should always be the same. It's always going to be in my app_data folder as long as it lives within my project. Right? And it's going to execute from the current directory. So at this point, we now have a connection object with a connection string. We've created a database. We've encapsulated it all inside of a data repository class. And if all things work as they should, we should be able to call this method getPatients, and it should run successfully. It should be able to build the connection object, open the connection. That's all we're doing. It'll hit the bottom of the using statement. It'll close the connection. It'll return an empty list of patients, but nothing will blow up. So if we go back to our form designer, double click for page load, the page load event, I can come in here and I can say data repository repo equals new data repository repo.getPatients. And what this should return is all my patients. So we're not doing anything fancy at this point. We're just making sure that our mechanics work. Everything we've done up to this point is true and it's solid, and before we get too far ahead of ourselves. F6, compile, build success, F5, run, and it works. It works because the moment that form loads onto the page, those two lines run. I'll prove it to you. F5. So this line is about to execute before the form actually appears on the screen. If we step into it, it's going to build all patients, declares these variables, hops into the using statement, makes a connection object, sets our connection string. So that's our connection string. And actually it should fail, but I don't have anything in my catch block. So if we step through, connection opens. Oh, it didn't even blow up. Well, that's interesting. bin debug. Oh, well, look at that. It even deployed it for me. All right, so in older versions, what would happen, we have this app data folder. The app data folder actually lives inside of our project. When your project compiles, it gets moved into the bin directory. So the exe that's running runs out of bin debug. This must be a new feature in 2012. Prior to 2012, it would not have been smart enough to say, oh, we should take that app data folder and move it inside of the bin directory, because that's the context where the program runs from. Normally, you have to say, go up 2 levels and find the app data folder in there.
Why didn't the models folder get moved?
Because the models folder was compiled. So it actually gets sucked into the exe file itself.
Okay.
All right? So that kind of goes to my convention, is that normally it knows not to move anything into the bin directory. It knows that it all either has to be sucked in or it's some sort of external resource. My guess is that because I use the app data convention name, which is the same convention they use in ASP.NET for their data directory, it probably knew that it needed to be sucked in by default. There are properties on these folders that talk about what to do with them. On that. No, it must be because of what it is. All right, so if you look here, so your question about the models, why didn't it copy the models? If you look at one of the C# files, look at the properties of that file. So I'm in the Solution Explorer, I clicked on a file that actually changes my properties dialog to reflect the properties of that file. The file has particular properties about it as it pertains to the project. Upon build, the build action is for that file to be compiled. It should be sucked in during the compilation process and be included in the exe or DLL that's generated during compilation. The copy to output directory specifies whether the file should be copied to wherever the compilation occurs. Where does that exe or DLL go to? The bin directory, debug more specific. This is set do not copy, so it doesn't copy it. You can run custom tools and custom tool namespaces, which are actually libraries that you can build that you can have run against these files before they compile. If you have certain cleanup processes you want to do on the files or certain optimization changes you want to make that maybe it's relevant in debug or development, but it's not relevant in deployment. Those are things that you can do, and then the file name itself. So the C# files are traditionally always compile, do not copy. If we look at our MDF file, because we brought it in through Visual Studio, it set these properties for us. The build action is content. We have compile, content, embedded resource. Embedded resource means don't compile it, but suck it in during the compilation and make it a resource that's embedded inside of the compiled file. Code analysis, dictionary, page, there's a whole bunch of other things. Some of them are relevant, some of them are not. Oh, let's leave that as content. So then, because it's flagged as content, the thing we next say is copy to the output directory. Copy always. We have do not copy, copy always, or copy if newer. Because it's marked as copy always, it's copying the actual file, and I guess it's taking that directory structure with it and copying it into bin/debug. So that's why we're getting it there. So if your project has images or audio files or any sort of resources that you want to have come along for the ride, when you do the build and run, make sure you set these accordingly, and then they will come along for the ride so you don't have to worry about relative paths and backing up 2 levels and dealing with all of that. Everything gets moved where it should. So that's a surprise to me. I did not know that it set those by default. So that's a good thing. So that means that our code did run successfully. Everything worked as it should, and just in case we do run into an exception later, I'm going to put a throw there. So that code runs, it goes out, connects to the database. We're obviously not running any commands up to this point, but we've now successfully made a database connection. Everything works as it should. Good deal. All right. Let's see. We got 10 minutes. All right, so we'll establish a connection. We'll run our command to select data out, and then we'll take our break, and then we'll work on how do we take the data from the database and put it in our objects. All right. So to initialize command, we can do command equals new SQL command. SQL command also will take the command text, and that's basically your SQL query. So if you launch SQL Management Studio, you make a new query, you type in your select star from TBL patient, that's what it's looking for in there. You can also pass the text and the connection object all at once. Or you can pass the text, that's the command, the connection object, and you can actually pass a SQL transaction object. Did you guys ever cover transactions? Did you cover how to define and roll back and commit transactions in a database? Okay. So what you do is think of an ATM machine. You walk up to an ATM machine. That is a transaction. It's a complete transaction. You start by you stick your card in. Most of the new ones now, it seems like they pop out right away, and then they ask you for your PIN number. So you put your card in, pop in your PIN. Transaction begins. What do you want to do? I want to do a withdrawal. I want to withdraw $100. Enter. Are you sure you want to? Yes, enter. So the machine then fires up that transaction, says Kevin is withdrawing $100 from his checking account. It's then going to go through a series of checks and balances. It's going to go through and say, A, does Kevin have $100 in his checking account that he can withdraw? Yes or no? If I do, it goes on to the next step in the transaction. It says, withdraw that $100 from the checking account. It wants to capture that $100 as soon as possible. The next step is there $100 in the ATM machine to give Kevin? If there isn't, the transaction object would allow the ATM machine to roll back the entire process. So let's say that there's money in the account, there's money in the ATM. The ATM then goes to actually spit the money out. It goes and it counts the bills, it goes to spit out the money, and all of a sudden there's a mechanical failure inside of the ATM, and it literally can't spit the $100 out. So you've committed the transaction, you've actually withdrawn the money from the ATM, but there's a mechanical failure. So you have this transaction object that you hold on to throughout that process that, again, allows you to roll back. Without a transaction object, you don't have that functionality. Now, do you need that in most cases? No. Very rarely do I have a complex enough transaction that requires a transaction object to be passed from query to query to make sure that everything commits in sequence or everything gets rolled back. When do you need them? Monetary transactions of any sort, you probably want them in there. Personal preference, I hate dealing with money. Just all the checks and balances you have to go through. But that's where you would want to make sure that you have that functionality. If you're dealing with somebody doing an online order, managing any sort of inventory, anything like that, you want to have these checks and balances to roll back. So that's how you would do it. All right, so we can say new command. Alternatively, we could say command equals con dot create command. That's actually my preferred approach, is the create command. What does that do for you? That puts the responsibility on the connection object to give you a command object that it can integrate with. So if you actually build your application, and we'll talk about this in a couple weeks when we start talking about interfaces and coding against interfaces, you can actually create all of these variables up here, your con, your command, and your reader, to not be SQL connection, SQL command, and SQL data reader, but you could declare them as being DB connection, DB command, DB data reader. Or you can make them IDB connection, IDB command, and iData reader. So you don't really know specifically what type of connection object you're getting, whether it's a SQL connection object, an ODBC connection object, or an OLEDB connection object. But you do know that that connection object complies with that interface. So you're coding against the interface, knowing that this is the expectation of the interface, this is the contract for this connection object. And then you rely on the objects to know about one another. So then you say, connection object, get me a command object. I don't know whether you're SQL, ODBC, Oracle, MySQL, any of the above, but I know that you're smart enough to get me the appropriate command object. So that's the preferred approach. Then, setting the command properties, you have command text. And your command text, again, is just that select all from TBL patient without an R. I'm actually going to move this up here, get it out of the try catch block, because I really shouldn't run into any issues with creating the command object and setting the string. When things start to get a little dicey is when you start to open a connection and you start to execute commands. If you forget to open the connection and you attempt to execute the command, you have to open the connection. Let me just say that first. You have to open the connection before you execute anything. Otherwise, the command object is going to say, hey, connection object, go run this query, and the connection object is going to go, closed, sorry. So you have to tell the connection object to open the connection, then you tell the command object to execute. Now there's a lot of synchronous and asynchronous processes here, and I'll talk about those when we get back. But we have execute non-query, execute reader, execute scalar, and really those are the three. We're going to execute a reader. What it's going to return to us is a SQL data reader object. So if we compile, again, it runs at the moment that form loads. So that means that we were successfully able to connect to the database and execute that query, and we receive back a reader that's now ready for us to read data from. All right. Look at that. I even stopped before 7. Check me out. All right. So take our 10-minute break, and when we come back,